Hello guys, it's your guy Vera. Welcome back to the Rocket Series Academy with VMS Project 14. So in this tutorial, we are going to be generating the M&G code required for VMS Project 14. Let's get started. Looking at the CAM path definition, we are using CNC ITAR controller, coordinate system. We got Mach 1 for the main face and Mach 2 for the back face. Go for the green check. Stock definition. We are using cylinder 0.02 for the main face and -2 for the clamping. Go for the green check. Target. We are using our CAM model as the target. Go for the green check. Proceed. The setup definition has been done in the previous tutorial. So moving to the main spindle, facing operation, show geometry. For the geometry, we got this face. Of course, we are working with Mach 1. Tool, we are using an external cutting tool of angle 55 degrees. Technology, a roughing pass, and of course a finishing pass with compensation on. Looking at the simulation, next operation, we have turning operation. Looking at the operation, geometry, we are working with Mach 1. Our turning begins from this chamfer point right up to the end of the path. Tool, we are still using our same external tool. Technology, we are using a roughing pass. No finish, strategy, non-descending. Looking at the simulation, the next operation, we have to machine this semicircle. For this, we have to use groove operation. Looking at the operation, geometry, we are using Mach 1. Our geometry begins from this groove right up to this other groove. Tool, we are using an external groove tool of A.04 and W.04. Technology, we are using a roughing pass and of course a finishing pass. Looking at the simulation, so we are left with this other groove. Just by using save copy. Next operation, still working with Mach 1, show geometry. For this groove, we begin from this end right up to this surface. Tool, we are still using our same external groove tool. Technology, we have a roughing pass of 0.02 and a finishing pass with compensation on. Looking at the simulation, as you notice, we got some raw material left. Next operation, turning operation, finishing operation. Looking at the finishing operation, geometry, Mach 1, show geometry. We begin from this chamfer right up to the end of the path. We are still using our same external cutting tool of angle 55 degrees. Technology, we are using finish only, and we have a step over of 0.004 with compensation on, strategy descending. Looking at the simulation, next operation, we have thread operation. Looking at the thread parameter, We got an external thread of measure diameter 3 by 8 and depth per inch of 16. So in order to have the pitch, we take 1 divided by 16. We are using the unified metric thread system. Geometry, we are working with Mark 1, show geometry. Our thread begins from this chamfer right up to this chamfer. Tool, we're using an external threading tool. Looking at the tool parameter, we are working with triangle. Thread type, we got UN. So just by coming in here, you just select UN. And then you find for the thread specification, we have 3 by 8 times 16. So you have to select this and go for the green check. Technology, making sure long external should be selected. Thread standard, UN selected. Same step, find for 3 by 8 60 and go for the green check. Step down, we are using a step down of 0.005. Thread finish selected. Looking at the simulation. Operation done. At this timing point, all the operations on the main spindle has been completed. We want to perform the operations on the back spindle. For this, we have to make a path transfer from the main spindle to the back spindle using the MCO. So this has been done in the previous tutorial. Kindly check the videos. Jumping directly to the back spindle, looking at the first operation on the back spindle, facing operation. Geometry, we are using Mark 2. Looking at the geometry, we have this face, making sure that the arrow begins from the top right to the center and not otherwise. Tool, we are using our same external tool of angle 55 degree, making sure that this direction should be selected and not this direction. We are working with back as mode, of course a roughing pass and a finishing pass with compensation on. Equally, we are using a step over of 0.004. Geometry, Mark 2 selected. We are using this point or this chamfer point. Otherwise, you could select from this chamfer right up to this end. Tool, we are using our same external tool. This direction should be selected. Technology, finish only. Strategy, non-descending. Looking at the simulation. Operation done. Next, we have to drill the hole and then tap it. If you just select the outer part of the hole, as indicated downward, we have a hole of 0.42 inch. So our drilling tool should be 0.42 inch. Looking at the drilling operation, coordinate system, no coordinate system. Remember that when we are working with mill 10 or turning system, we have no coordinate system for the hole. The hole is always at the origin. Tool, we are using a simple drill of diameter 0.24 inch and length 5. Go for the green check. Technology, drill start. This should be the drill start. Drill end. Just select this line. Go for the green check. Full diameter activated. You can use a peg cycle if you wish. Looking at the peg data, I'm using a peg cycle with step down 0.025. Full retreat, no. Go for the green check. Looking at the simulation, operation done. Next operation, tapping. Coordinate system, we are using Mark 2. Tool, we are using a tap tool. Looking at the tap parameter, firstly, we are using a tap tool for the internal thread of measure diameter half and tap per inch of 13, and we are drilling by 0.4 inch. pitch. For the pitch, we have 1 divided by the tap per inch, in this case 13. So 1 divided by 13. Measure diameter, we have 0.5. Tool length, I set the tool length to 4. Go for the gain check. Delay end, 0.4. Delay cycle, making sure tapping should be activated. Data, step down of 0.004. Looking at the simulation, at this timing point, we are done with the operations on the main spindle and the back spindle. Selecting the operation and using the channel synchronization in order to synchronize the main spindle and the back spindle. So what you want to do here is simply save calculate and then simulate. Solid verify selected. Looking at the full simulation, no collision detected, operation properly done. With this, we are done with VMS project 14. If you have any question regarding this project, do well to contact us by Facebook or by email, or even leaving a comment in the commenting box. Keep liking the video, keep sharing, keep commenting. Thanks a lot guys. See you guys in the next tutorial.